So let me just put down how we are planning this batch. So initially, for first 2 weekend, I would be covering the foundation, and post the 2 weekends, I'll start with the CCNP, and I would be going both at the same time. That is Encore and NRC. You might be aware that Encore is the mandatory paper, and NRC is the concentration paper, or also you can call it as advanced routing paper. And post the CCNP completion, or parallelly, because we are planning for a batch to run for SD1 parallelly, might be after a 2 week or something. So you guys can also be take part of this. This would be weekend 10:30 a.m. for 2 hours. Okay, it's IST time based. So this way, both your batches, that is CCNP and SD-WAN, would be going parallelly. This is 30 days of course, whereas this will take at least 60 to 70 days of the course, the Encore NRC. And post that, we will be going with the CCI boot camp, and at the same time, I'll be covering the DNAC and the rest of the topic here. Okay, so that is the process. So right now we are on the step one, which is Encore and NRC. So those people who have enrolled only for CCNP or to CCNP and SD-WAN, or else to the complete package. So for you guys, you receive Encore and NRC. And for the second option, you get Encore, NRC, and SD-WAN. And for the third option, you get Encore, NRC, SD-WAN, and the DNAC topics. Okay. So you know what have you enrolled for. There are people with just enrolled for CCNP, or some could be for CCNP plus SD-WAN. Some could be for the CCI package. Okay. So whoever it is, remember Encore NRC remains the same. That's why we will get started with the basic module, Encore and NRC module. So let me show you about the Encore paper. So this is a core paper, which also nowadays serve as the written paper for CCI Enterprise. Okay, the Encore paper is acting as the core paper, and also acting as the written paper for the CCI Enterprise. This is 120 minutes of MCQ. It used to be MCQ, but nowadays they have also included some scenarios based to the exam. Okay, some scenario based design kind of questions. So it won't be troubleshooting paper, but it will be more like MCQ based plus scenario based pattern, or you might have a bit of labbing to be done on the Encore topic. So this the official certification and the cost you can also find in the official book or the guideline. Regards to the NRC, this is the advanced routing paper. And once again, if you know under the enterprise topic, you have the core paper, which is NCO, and then you have close to seven concentration papers. So you can select any one from the concentration paper. So you have NRC, you got SD-WAN, you have N auto, that is towards the automation, right? So you have certain seven papers here. So we are covering NRC, plus we would be also covering the SD-WAN, and then we have something for DNAC as well. Okay, so that is from the concentration paper. These papers are optional. You don't have to mandatory write them. However, if you write them, you get a specialist badge as well. That you are a specialist in enterprise and let's say implementation. Or if you clear the SD-WAN concentration paper, then you get the badge called specialist in the SD-WAN topic. So all the concentration paper once you clear along with the mandatory paper, then you become a proper CCNP certified plus the specialist badge for that particular concentration paper you might have done. Someone who wants to go directly to CCI, for you only encore is mandatory, and then you can target the CCI lab of 8 hours. For you, the concentration paper is not needed if you don't want to spend money on those concentration paper. How to find the topics or how to find the blueprint? Very simple. You can go and search for Cisco CCNP Enterprise Blueprint. So it will take you to the official link. Click on explore exams and training. Let's say exams and training. So this is Encore exam. Open the PDF. Okay, and this is how you download the needful PDFs. So usually the encore paper, the mandatory papers are like as usual, like your CCNA structure. You would have 6 chapters. Each chapter has certain weightage. You can find the weightage over here, right? The encore paper is more of conceptual topics. You don't have any in-depth practical here. You don't have any major protocols to be discussed, or you don't have any major uh, in-depth from any topic. More or less, it will be generic and focused on all the enterprise levels, safe routing switching, then the security, a bit on the wireless, one dedicated chapter for automation, virtualization. So this encore topic is too generic. So you will get to lab topics like let's say spanning tree protocol or ether channel, right? You don't have DTP now. You don't have let's say CDP, LLDP. But we would be covering from our foundation basis where we will touch base this important protocol. And same as routing protocol, you don't have much of routing protocol, at least in the Encore paper. But since we are going hand by hand with Encore and NRC, so I'll start the routing topic for EIGRP and OSPF, BGP, and we will check the concept and we will also lab it. Okay, so we would be going Encore and NRC hand by hand. So I won't be taking first Encore and then I go to NRC because most of these topics are something which you should know from the enterprise level, routing switching point of view. So I would be going with my curriculum. First, I will pick up the switching topic. So under the switching topic, I'll complete spanning tree. Then we go to RSTP, MSTP. Then we go to Ether channel. We will look into the CDP and LLDP, like the regular switching topic. Once we have done this switching, then we go to the routing topic, and there we will discuss with EIGRP and OSPF, BGP. Then we go into the IP security. Under the IP security section, I'll cover let's say GRE tunnel, IPsec tunneling, DMVPN, right? And also under the security, we would cover some layer 2 attacks and security attacks related topics too. So this is how my format would be proceeding. I will not follow straightforward the blueprint because it's too generic. You will find most of theoretical topic without the labs. So if you see the chapter 1, 15%, most of them are concept without the lab. Same when you go to virtualization, you will see this is a described topic. You have some configuration here and again described topic. When you go to the layer 2, you will find that there are certain topics related to switching like we
मैं
discussed.
अभी रिमाइंडर भी भेजा उनको मैं
Guys, be on mute if you're not speaking. Okay, so this is the topics here would be more generic method. You might get some time lost if in case you don't go in a step by step order. So I'll come up with the topic first for the switching, then the routing, and IP security or IP services, virtualization, and etc. So that is how my even the notes that I have in the G drive, which I'll be talking in some time with you. So that's also classified or categorized in that way. So if you see the notes that I have put up in the class zero, I'll talk about where you get this thing. So I've divided them into certain categorization. So this would be our switching topic initially. Then we have the first hop redundancy protocol. Then we talk about routing. Then we talk about IP services, IP security, network assurance, network programmability, wireless, and virtualization. So these many categorization we would be covering both Encore and NRC. Okay, so that is how I have just categorized each and everything so that we don't go in such a way that we only touch base the concept but not the lab, and it's difficult for someone to understand the topic from the in-depth level. Okay, and I don't prefer having preparing the preparing lot of presentations or slide. Whatever is there, I will try to write it on the screen, or I will do it over on the lab, or I have my lab workbook which I will go through and explain how that topics works and how that labs work. So if we open, let's say, one of the topic from, let's say, IP routing. So the notes are prepared from the practical perspective rather than textbook screenshots or textbook things where you have lot of words and lot of sentences. The notes will be straightforward rather than having too many twists and turns. So let's say you want to go through the OSPF topic, all the things would look like something very easy to grab. Okay, so it's not something like you have something from let's say textbook and we would be practicing or we would be going through it. Same with the workbook. You will have a dedicated set of workbook. So when you open the workbook, so this is the workbook. You can go to the topic of your choice if in case you're practicing OSPF today. The lab diagram would be shown to you. The topology is put up in front of you. The task is given to you. You can follow the guidelines to configure it and check the validation. Or if you do not know step-by-step process, then you can also find it in the workbook and you can practice it. You can see the comment, you can see the validation step that you get, the things that you have to verify, right? So that is how it works. I would be showing you directly the workbook sometime to show you the topic and to make you understand. Okay, I don't prepare too much of presentation on PPT and all those things once we are done with our 2 weekend of presentation. Only for the initial presentation, I've kept some PPT just for everyone to be on the same pace and same level before we get started with the topic. So let me open that first few classes presentation, and that is what I was having some time back. Okay, so before going to this basic topic, I also want to tell you the materials that you would receive from our side. So by now, I think you already have received the welcome kit email from us, right? So anyone who has not received it yet, I think every one of you have received it. In case if you have not received, you can ping us back on the common WhatsApp group saying that you have not received. If in case you have received it, then you might have seen that you have received the access to our Learn portal. This is where these videos that we are having right now a live class. So also find all notes and the PDF that I was showing under class 0. Okay, so we have made a section called class 0. You will find all the references to notes, workbook, right? And the home lab file as well. The OVA file that you need to run on your system. And also the second component that you receive is the remote lab access. Have you guys validated if you have access working on the remote lab? Anyone of you have opened the remote lab and made sure you have the access?
I tried. I don't have access.
Okay. Okay. So the second component was remote lab access. The team has given you have given you an public IP kind of concept like 106 with some extension with the login credential. You log into that and make sure you have the access to it. The third one is the home lab setup assistance. Now, what is this? Say, for example, you do not find the remote lab access more engaging or more convenient. Though we have given you 24/7, but for some reason, let's say you want it on your own laptop. So we have also put up that ready-made file under the class 0. So you download that file, reach our backend support team. This is our DL, support at the rate networkjourney.com. You reach to us stating you have downloaded that file with the extension OVA file, which is usually 30, let's say 30 GB. You have downloaded the file and you need someone from Network Journey to assist you. So our backends are available morning 9 a.m. to 6 p.m. IST. Get get that done on your home lab if you need the assistance, and make sure that this is on your own laptop. So minimum 16 GB or above RAM is more or most preferable. 16 GB RAM with, let's say, 8 core or 6 core CPU, and 100 GB of the storage. If you have this specification in your laptop, you can have it run on your machine. If you don't have it, like you have 12 or 8 or 10 GB RAM, then I would say that you try with the remote lab itself, because the home lab would be very slow for you. You may not be able to work efficiently in that kind of receive with the welcome email, which you can check later after today's class. And if in case you have not received, you can confirm to the backend and they will help you to fix the issue if you in case you're facing any issues. Okay. So any question so far? So any questions so far?
So far, good, sir.
Okay.
Yes, sir. Like you were talking about 60 classes for the CCNP.
Mm-hmm.
60 classes, you mean to say like 2 months or like each class, like we will be having 60 classes? Like, I didn't understand that.
I mean, don't worry about that part. I mean, it until the the topics are there, the classes would be going on. But let's say 60 classes in the sense, it will take minimum 3 months, I believe, on weekends.
We're having classes both on Saturday and Sundays.
Yeah, correct.
Thank you.
Okay, so Saturday, Sunday, 6 to 9 p.m. The classes are. Initially, few classes might be shorter because the participant are also not joined today. So might be today we can have only 2 hours of session, and later as we start, and also remember the annual shutdown is also going to start. Then the people will start dropping it from 21st. So we have to consider that as well, and we have to resume back once from the Jan month in that case. Okay, so we will plan it in a better way so that people don't drop out and start missing out the classes. So from 21st, people will start getting the vacations, and then they don't join any such classes and start spending the time with their families and start dropping the things. Okay, so we'll discuss that later, and we will also let you know from when the annual shutdown starts and when we resume back. So I'll make sure that no one misses your the classes due to these upcoming things. Okay.
So sorry to interrupt. I do have a doubt.
Yeah, yeah, go ahead.
You said that the SD-WAN we can go it in parallel.
Correct. Yeah.
But if we are unable, if in case, in my case, if I am unable to join in that way parallelly, will there be sessions soon after the NRC?
Yeah, yeah. We will be running this SD-WAN once in a month every time. So if you are not comfortable with this batch, then any other batch in any other slot, if you get to know that network journey is organizing, you can attend that.
No, sir. Soon after the NRC of this batch, in the same very same time, will you
Yeah,
be
yeah, that
running the
that will also
NRC?
come. That will also come, but for that you have to wait 3 months. So if in
Okay.
case you see network journey is having any parallel batches, like now we have in the morning, sometimes we might have week days, or sometimes we might have it in some different slot, and you want that to also get started, you can let us know, and we will place you in that group as well. Otherwise, you have to wait for 3 months after NRC. We will be starting SD-WAN.
Duly noted, sir. Thank you.
Okay. Okay, so how you are from I mean, what is your level of understanding in the enterprise, or might be are you from a different from a different background? So can you give me a quick intro from your background level? It will be easy for me to also understand.
Hi, Sagar.
Yeah, Rahul. Yeah, go ahead.
Yeah, so I have about 14 years of experience, primarily into wireless field Wi-Fi, and I have about couple of years back I have completed the enterprise and advanced NRC certification. So I'm slowly also trying to work on my wide skills. So that's why I've enrolled for this on-core plus NRC batch. Yeah.
Okay. Okay. How about others? Sai Aruna or Abdul or Michael.
I have I had my CCNA before and I'm just in the process of renewing it. But also when I saw the opportunity for a CCNP, I decided to do that as well.
Okay, yeah, sure. So are you working professional, or you're starting with your career?
No, I have been working, but not in networking. Been trying to get into networking. That's why I try to keep my skills up, but have not been able to secure a position in networking yet.
Okay, okay, yeah, sure. Okay, how about others?
About me, I do have CCNA.
Mm-hmm.
I'm into the networking, but trying to build it to take it to the next level.
Mm-hmm. Okay, okay.
I have about more than 10 years of experience in networking. I'm rightly working on Fortinet and Cisco products,
Mm-hmm.
but still, like SD-WAN and DNA, it's new to me. So I'm trying to brush up my old uh, knowledge and as well as get the new one.
Okay, okay, yeah, sure. Okay. Okay, I think only Christian is pending. Chuck, have you also
Yeah,
shared your
yeah.
background?
So sure. It's about 7 years of experience. I have CCNA, and again, I also want to get take the CCNP exam. Haven't done that yet, and
Oh,
then yeah, want to do both that Encore and an RC. Yeah.
okay, okay. How about Christian?
I have a CCNA, and probably been working like 2 years in the networking team. And aside from that, I have 1 year working in a data center.
Mm-hmm. Okay, okay, all right. Okay, fine. So I got some clue now about our participant background. So I think we can start with some foundation topics to have all of our participant on the same sync and the track, not less, not more. So we will start with very basic fundamentals first. Do you guys know? Do you guys know the difference between these, like LAN, WAN, these, and how are they different to each other? Like what happens here? What happens in the WAN? Any protocol that you are aware of LAN? Any protocol that you are aware of WAN?
LAN is basically you're talking about switching. It is within our premises, where WAN is something where we connect to the different branches or internet. Mostly the protocols what we use in LAN is STP and mm, VRRP and other stuff. Like in the WAN, we use most of them routing protocols like EIGRP, OSPF, BGP, and then we have some other technologies like MPLS.
Okay. Anyone else? How do the other support this answer?
Sounds pretty good to me.
Okay, see, there is one miss in that. I'll tell you from that protocol point. EIGRP and OSPF are the LAN protocols again. Okay, your WAN protocol is only BGP. And rest whatever you said is correct. STP or CDP, LLDP, DDP, Ether channel, uh, HSRP, they all comes under the LAN itself. So not all the routing protocol should be WAN. You also have LAN interior IGP protocols, Interior Gateway Protocol, which runs within the organization. Okay. So within one organization, you need routing protocols if in case you have multiple gateways or you have multiple floors in your building. Each floor has different network. So to interconnect them, you need this routing protocol. Okay. So we will discuss about the network component. So now you can see here, these are all the LANs component. So these are end devices. End devices in the sense like the scanners, printer, fax machine, Xerox machine. They are all the end devices. Even these are called as end device or end users, we call them. Okay, they can be from a different team. Say, for example, this guy is from sales team. This guy is from marketing team. Let's say he's from engineering team. Let's say this is from HR team. Let's say this is from uh, let's say from the IT department team. So how they are connected? They are connected to a switch, L2 switch, and that switch is then connected to L3 device. So L2, L3, we usually use the short form, but the full form is layer 2 and layer 3. So from which aspect are we talking about layer 2 and layer 3? From the OSI layer aspect. So this is a conceptual topic here in the IT networking to understand the network in a better way. So there are 7 layers, starting with layer 1, layer 2, layer 3, 4, 5, 6, 7. And on the receiving side, it is, so say for example, this is source, and this is destination. Right, in the IT networking, the source and destination plays very important role. You can also call it as client and server. So this is client, this is server. You can also call source and destination. That means this is a initiator, this is a responder. These are the usually used terminologies in the networking. You can call initiator, responder, client, server, source, destination. Now, in this case, if a packet is moving from source to destination, also it will be expecting some response back, right? Whether the packet has reached, whether the packet got missed in between while it was transmitting, or the packet got corrupt, or the packet didn't reach due to any XY reason, right? So there is a concept called OSI layer, which has 7 layers. So here from the layer 7, it goes in a top to bottom order. 7, 6, 5, 4, 3, 2, 1. And then the analog signals pass on via the cables. Okay. And on the receiving side, it again goes from 1, 2, 3, 4, 5, 6, and 7. So at one side, it is top to bottom. On the other side, it is bottom to top, like descending and ascending between source and destination. So at one side, from the graphical application layer till the wire, on the other side, from the wire getting reassembled and getting it back into the presentation and visible on the screen, right? So this is the 2 steps that happens behind the scene. So that is where this layer comes. This is now from the layer 2 of OSI. This is from the layer 3 of the OSI layer. As per the layer 2, they are meant to handle or meant to deal on based of MAC address. They do the work of broadcasting. Okay. Whereas layer 3, it works on the basis of IP addressing, and they work on the unicast concept rather than broadcast. So if you send any broadcast, the routers will just drop the broadcast packet over there. So these users with the different from belonging to different team are connected to a switch. Then the switch is connected to router. Router, if the user, let's say he is a user who is trying to browse LinkedIn, so that needful rules have to be present in on this firewall. And the firewall, if it allows to the internet, then only that user will get the return traffic and he will be able to use it. If you have restricted all this social media networking sites, then basically he will be getting drop at this point, saying that LinkedIn is blocked. So this is how a LAN facilities would look like. You will have the LAN components like end devices, then the access layer. This is also called access layer. Access layer. In right now, this is directly connected to the core. Might be this is a small or medium segment enterprises. But in a case of large scale, they also keep distribution layers. Okay. So in that case, what happens is, let's see in that case what happens. So let's say these are users from a different companies. Okay. Now they are all connected to layer 2 switch. Layer 2 switch would connect to a router, which is, let's say, layer 3. And let's say on top of that, you have directly the internet service provider. So in this case, it looks to be a small scale or medium scale enterprises. That means almost like somewhere like less than 50 users or less than 70 users, or might be max less than 100 users. So in this case, the router with that you have, it will act as the gateways for all this end user. You know what is the gateway? Say for example, if you open your laptop, when you go to the network adapter, you see some IPs there, like 192.168 1.1 with the subnet mask 255.255.255.0, and then something called gateway, let's say 254. So this gateway is basically this IP over here. So let's say if this interface is called FA0/0. So what the network engineer does it, they will go with the concept of subdomain, or not subdomain, sub interface. So let's say they make it 0.10, and they configure this gateway over there. They mention that this is 254. Similar way, you have another user. Let's say he's from marketing and his IP is 172 1.1, and his gateway is 172 so and so. Now on the same interface, you will have FA 0/0.20, and this will be representing 172. Okay. Now this is called gateways for your LAN users. Gateway for your all the LAN in the sense the end users basically. So if someone asks you where are the gateways of the end users, so you should know that whatever gateway that you configure on the end device, where is that pointing to? So in the case of small or medium, that is directly pointed on the core devices, and the core device also will be connected with ISP. So here you will enable BGP, you will enable the NAT rules, you might have the ACL rules there. Right now this core device is having, or it is doing all the work, that is gateway resolution, then on uplink it is having BGP, NAT, ACL and a lot of other things. So it is okay if you are having a limited set of user, but definitely this is not going to be okay if, let's say, you had more than 200 users. So in that case, we have to bring up another layer which will be taking care of the LAN gateways, and the core router will only be taking care from the ISP perspective, might be BGP, NAT and ACLs or whatever restrictions that you want to add it. Okay, so this is also called as collapsed network diagram, where you have core which is also acting as a distribution, and thus access layer. Okay, so this is called access layer, and this is called core or the distribution layer, or it is also collapsed concept. Okay, this is when you are having a smaller segment. But when you go to a large scale, then the things will change. So let's say you have users connected with layer switch. Now, not the layer switch is not directly connected with core. Instead, there would be distribution devices like cat 6500. Okay, cat 6500, or any switches, like nowadays you have cat 9K. So these can act as a distribution switches. And core, as it says, it will be connecting to the ISP. Now, where are the gateways of this? Let's say this is from sales team, this is from marketing team, this is from the engineering team. So where are the gateways connected? The gateways are now connected here. So you will configure the gateways here. Let's say gig 0/10. You have 0.20, 0.30. So let's say this is belonging to VLAN 10, VLAN 20, VLAN 30. Okay. So this is sales. This is marketing. Let's say this is engineering VLAN. Right. So we have the three machines here: sales, marketing, and engineering. Now, these people, if they want to have inter-VLAN communication, then this device is being touch-based, the distribution device. And where is the core getting utilized? If this source or if this user wants to go out, then only the core is included, where you have, let's say, eBGP, you have, let's say, NAT rules, or you have the IPsec VPN tunnel. So that is all in the core router. Why we do this kind of segregation, or we do three layers? Considering that you might have more than 100 users or 200 users, and you don't want the LAN gateways on the same device, and due to a high resource utilization on a single device, the whole thing goes down, or becomes slower, or the your network reachability gets impacted. That's why we do use this kind of three-way architecture. So this is in the enterprise, we do use of this kind of architecture to avoid any latencies issues, or to have a better optimized way. So let me go back. This is how the LAN looks, and here is where those EIGRP and let's say let's say the EIGRP and OSPF and all this comes up. So let's say this is the LAN network. If in case I have multiple network on acting as my gateway, right? So if I have to advertise, or let's say if there is another floor on the same building, I have another floor where I have a very similar way. I have a router, I have a switch, I have my end users. So if in case this user wants to talk to this user, now this is has to be done via the internal routing itself. Like you can enable EIGRP, you can enable you can enable OSPF, right? You need BGP when you are going outside the network, that is using public IP. Whereas for EIGRP and OSPF, you're not using public IP. You're still using private IP because you're still in the LAN segment only. You need BGP when you're dealing with public IP. You need this EIGRP or OSPF when you are within the organization. You are using any internal communication. Let's say user is sitting on a different floor. Okay, you have a different floors. Let's say this is a floor 5, but your printer is on the ground floor, and you are sending a document to be printed so that you can collect at the time of logout, right? So for all this reachability, you need an internal protocol to be running, because you don't find yourself in a single VLAN. In a network, what we do in the organization, what we do, we segment the VLANs into many smaller network. So if you have a VLAN, uh, let's say you have VLAN 10 for something, VLAN 20 for something, 30 for something, 40 for something. So these all are in a different broadcast domain, and they will not talk to each other until you have some layer 3 devices with you, layer 3, or a multi-layered switch which also works both in L2 and L3. So if you don't have that, the VLANs would be they won't be talking inter communication. Okay, so this is where the protocols are needed. You can go through this word, they are all self-explanatory. Yeah, regarding the WAN, this is when, let's say, you have branch and campus and you want to connect a different branch and campus. Let's say these are the branch, and this is your campus in a different location, right? So you need this WAN connectivity. When I say WAN, you can think in this way, like you have a AT&T ISP, you have a Reliance ISP over here. Let's say you have a Vodafone connectivity here. So you're based on the service provider. How service provider deal with your network or your traffic, that is straightly that is completely with them. You will not have much control once your packet has left the LAN premise and is on the WAN cloud, because then it is up to them to fine tune your packet. So that we will see in the BGP when we talk about the path manipulation. So you will understand that there are some ways that we can tune our traffic. Let's say if I was receiving from this end, but I am getting some packet loss, and if I reach to service provider, might be they take 7 days to rectify or do the path optimization. So I will go with the BGP path manipulation, and somehow I will, let's say I will put the AS path attribute manipulation and try to show this path as the longest path, and try my packets to go from the shortest or best path. Okay, so at the time of path manipulation, we will see that how within our control we can do, we can say that I want from this link, not from that. So for that, you should have the connectivity, otherwise it's not possible. So in some cases, what happens is you might be signed up with two ISP. Like let's say you have AT&T here, and also you have Vodafone here, right? Let's say both are 5 Mbps, 5 Mbps, 5 Mbps. Might be you are receiving all the data from this, from the WAN, but for some reason you're not happy with that, right? So in that case, you can make use of the BGP path manipulation to somehow say that this is not best path and you would prefer to go with this. Okay, that is under your control. But let's say you don't have BGP the circuit and show them that you get the ping result or the traceroute over on this with this millisecond, whereas from this you receive this. So they will try to troubleshoot, and they can either cut down that connectivity and make your packets to go via the one which is having the better optimized path. Okay, so for that case, you have to depend on service provider. If you don't want to depend on
We cannot hear you.
uh,
Your voice is breaking up. Cannot hear you.
how about you now?
Okay, now it's good.
Okay, so how long back you lost the audio? Is it now or
When you did your WAN diagram, you were talking about BGP, and that's when we lost you. I think we still lost you. Can't hear you.
I think when it flips to the microphone, I get disconnected. So I'm connecting back to the laptop audio. Is it okay now?
Yes.
Okay, fine.
Yes.
Okay. So we were talking about the WAN and where do we use WAN and the BGP path manipulation. There is also there's also a website where you can see the major the cables or the fibers that's connected beneath the ocean. It's called as submarine cable. So there is a myth that the IT networking, the packets are carried over on satellite, or it's all wireless. Let's say, let me be very clear. Let's say, so let's say if you have laptop at home which connects to modem or router, right? Because this might be the wireless reachability over on Wi-Fi. So people think that we are connected to the router over on Wi-Fi, and we don't know behind the scene because we don't touch anything beyond it, because the technician comes and give us the connectivity. So might we sometimes consider might be that's taken to satellite, and might be that is how the IT networking works over on wireless. right? Let's say on the other side, if there's a person once again connected via wireless laptop, right? So this approach is wrong. We are not connected via satellites, okay? We are not connected via satellite. We are connected all via data cables. So there are different type of cables that's available. We have optic fiber. We have the cat LAN cables. Okay, cat cables you can call, or LAN cables you call. So these are two primary used cables for the data communication. What you have at your home, let's say the laptop, and let's say you are connecting to the router, might be that is via the Wi-Fi connectivity, or you can call it as wireless, but that is only a range of 10 meters. Okay, 10 meters in the sense from one end of the room might be till your living hall, not beyond that the Wi-Fi capability is. And you also might have experienced, if you go a bit far away, then you start losing the signal. So the range is like only 10 meters from your laptop to your Wi-Fi. Behind the scene, what happens is the ISP people give you uh, the cables. Nowadays, you will find optic cables itself, optic fiber cables, which connects to the junction box. This junction box are usually kept on the terrace or might be on the ground floor below the staircase. So this is a junction box that the ISP has it, where your connectivity is being getting connected. Later from the junction box, they will have it connected. Let's say to the you might have seen that every time this people uh, you know uh, dugs the and keep laying down the fibers inside or under the roads, right? You might have seen that nowadays all that machine comes where they put these fibers and lay the cables from one side to another. So all the ISP does that. So every ISP will do this kind of cabling which lies under the ground, and now that connects to that. So it's all cables, but different type of cable that goes from one point to another point, and they use this concept of mux to because what happens, the packet can have the chances of dropping or losing the strength. So the mux will help them to improve the signaling, or to avoid losing the signal. So it goes to one point, then it will go to the next point, and so on. Let's say if your connectivity is between you know countries, well, let's say you are in India, and on the other side you're talking from a different country. So across the country, then this is what comes up. You should see this diagram. Then let's say you're in India, and you were trying to send some packet. Let's say you're trying to access facebook.com, and that facebook.com is located somewhere in one of these countries. So these are the different fibers that's available. So now let's say you're somewhere here, you know how the things went. It will connect to the your home router, then it will go to the different paths, and let's say your service provider, etc., within the line. And let's say then it is going to the one of the fiber, and then it will take this path. Let's say it has to go to Sri Lanka or any other way, and then it will take that path and move to the end point, and the receiving also happens in the same way, and all this happens in the millisecond. So don't be considering that since you see all this lengthy cable, it might take hours to get you back the response. It is all happens in the millisecond. So that is the speed of the things here. So this is just from your understanding point. You can go through, you can click on any cable, it will give you more detail about it. So let's say if I click on one cable, it will only show me the details for that cable then. if in case you have to check any cable, you can just simply yeah, this will be ISP specific. Okay, the tier one ISPs will have the cables later, and then the regional providers will buy the service from them. So that is why you will see that in your city you might have very XY named providers as well, but you will not find those cables laid up here. So only the big brands will have the cables here, like Tata or Reliance or Airtel and all those things. And later, the services will be shared or on a subscription base. It will be shared on the rural or urban location, and you might see a lot of regional providers, internet providers also. Okay, so we'll make a move. Yeah, this we were talking just a few minutes before connection medium. So this is one of the connection medium. It's called CAT cables or Ethernet cables. Ethernet is the technology here. Okay, so since 1980s till this, the Ethernet technology has been evolved. Okay, so starting with the CAT cable one version. Now they have gone till the one which we are using sometime back was Cat 5. Now we are using Cat 6 as well, and there are still more some flavors of the Cat versions. So we'll talk about this cables and the color coding. I'll go through this. And the second major connection medium is the optical fiber. You will see optical fiber in the case of uplinks. For the uplinks, you especially use the optical fiber. There are various reasons for it, because here you don't see your laptops are compatible with these channels, right? Because this cable size that you see, they cannot be directly inserted with any modem as such. So there needs to be some SFP modules. So some sort of converters are needed, and these converters are all costly converters that we can plug directly on a routers. If you know a router, the router has some switch ports, right? So there are some dedicated switch port which is capable for Ethernet cable, and also there will be one switch port which is reserved for the optic fiber SFPs. So these optic fiber SFPs, we put the exact converters, and then we plug it to this. Also nowadays at the home router, if you check, there would be some dedicated ports for WAN, and then there would be a lot of LAN port, local area network, wide area network. So the ISP will directly inject the cables. So as I told, in the enterprise, we come up with SFP design, SFP module, which can cost anything like 100 USD or 80 USD till 500 USD. But at home, the users don't prefer to again spend on them, right? So your modem directly comes with an option where you can insert the cable to it, and not directly insert, by some sort of procedure called slicing. So the technician has some tools or some equipments with them, where they put one end of this cable and do the testing. They will see if the signal strength received on that tool is, let's say, 99%, 98, 100. And then they just slice a part of this. You see that there's a protective layer with made of plastic and carbo components. They slice it, and this is made of glass basically. That is being injected to the home routers directly. Okay, just to avoid spending on additional SFPs. But at the case of the production, at the case of your enterprise level, we are talking from the professional devices like routers, right? So they don't have that option of directly injecting. So we have to make use of a SFP module converter. So that converter we have to plug it and then we can insert to this. So I'll show you how this SFP modules looks like. These are the modules, and I'll also show you how it see like this it looks like. So one end is the fiber. The fiber is being injected to this, and this is now directly put up to your networking devices. So let me search if there is anything. Yeah, you can see here. So you can see that there are certain things that is directly injected to that. So that happens when you have this type of SFP modules. You can see here also. So let's say this is one of your device. You directly cannot inject the optical fiber because they are made of glass, and the dimension of that and the dimension of this don't work. I mean, they don't are in the same shape. You need this SFP module. This comes in a different branding, different capacity. You get in a different model, the different pricing. So one of the one which is compatible with the device that you have to buy. Let's say this is your device cat 9K. So you should read the data sheet and understand what SFP modules are supported, and only that you can have it and cable it or put those fibers and then you can insert it. So that is how the ISP will terminate. And in the case of optic fiber inject to home router, is something like this it will be, where you directly inject to the point itself without the SFP module. So the design will vary from routers to router. You will see the various home routers uh, in a very very inexpensive way, whereas the production or in the enterprise racks, what we see those Cisco router and switches, they are very costlier ones. Okay, so we don't use them in the case at home. So that's also money matters there. So this the first option is the Ethernet cable that you use to connect your laptop and let's say your CCTV, Xerox machine, scanner, and all that purpose you use this. These are not so expensive. They are not very they're not very delicate as such glass, because this consists of cables, copper cables. So you can twist them 180-degree, 360-degree. They don't cut as like that this could happen because these are made of glass component. Though they have the 7 to 8 layers of the protective components, but still to some extent when you might make it like let's say 360, or you might uh, corner it, use it in the edges, there is chances the glass can cut and you might see the packet drops or the connectivity loss. So we'll see like how they are used in the office. So you can see the RJ45. They are being connected from a device to device, or you can see them connecting to the CPU or the behind the CPU. Or if you want to connect, uh, let's say any RJ45 purpose. You have a IP phone. Now, all that works on this. We also call it as RJ45 or Ethernet cable or LAN cable. they all mean the same. RJ45, Ethernet cable, LAN cable. Okay, so this is again an office setup. Let's say you have one switch is connected to all the end users, and you have a Wi-Fi router. Okay, this is how the the official Cisco switch looks like, which is working on the layer 2 of OSI. Okay, which works on the basis of MAC address, which works on the basis of a broadcasting the packet, or you can say broadcasting the frames. Okay, and you can see these are the switch port. This is where each end device is connected. So let's say this will go and connect to a PC. This will go and connect to IP scanner. This will go and connect, let's say, to some other endpoint. And the uplinks will be connected to these ports. These are some uplink ports. Uplink in the sense it might go and connect to the next gateway, or let's say your distribution switch. Whereas all the rest of the ports will be for your and end users, or you can say downlink. And these dedicated ones are for the uplink. Okay, so and the thing that you see here is this is single chassis, single fan. That means single point of contact for every component. So if a fan goes down, okay, if let's say the fan goes corrupt, or the power PSU goes corrupt, you don't have a concept of hot swappable. You might have heard when you talk to this data center technician. So hot swappable in the sense if a component is going corrupt or due to any hardware failure, you should be in a place of taking it out and do the RMA with Cisco and replacing it with the working model. That is called hot swappable, because in at the case of hot swappable, you will have two units for each one. Let's say for fan, you have two fans. So if one is going corrupt, you will take it out and you will do the RMA and inject the working one. So till then, this will be working. Same with the power supply unit. If one is going down, the second one is working, you will do the RMA for the non-working, get the replacement and do it. So your device is always serving the packet. You're not keeping your device powered off. You're always serving the packet. That is achievable when you have hot swappable concept. But right now this device don't have hot swappable. Even if a port goes down, you still have to send the entire unit, and at that point of time till you get the RMA device, you might be running dependency on the rest of the device in your production, because this is completely taken out of your network, right? So that is what the concept of dual soup or hot swappable, or this is called a single chassis device. That means only one unit here. So if it goes down, then you have to replace and wait for the RMA unit. And in a broad way, this is a switch. So that means you will expect a lot of users connected to this, and on the uplink you will see it connected to a distribution or a layer 3 router or a gateway. And let's say if this is connecting to sales laptop, this is connecting to marketing. So they don't talk to each other, right? Because this is on the VLAN 10, this is on the VLAN 20. So this VLAN 10 is only able to communicate with another VLAN 10. So let's say this is VLAN 10, then they will able to communicate, but not VLAN 10 with VLAN 20. That will not happen until you have your gateway. Let's say you have a router here. At this point, what happens is there is a concept of ARP broadcast. So the source will send a packet saying that I want the MAC address, or I want to have the MAC address of this IP. That means the destination IP. Now what happens is these are the different VLANs, right? When the different VLAN comes, the what this will do is it will send to its gateway. That gateway is nothing but this guy. It will send to this to understand where is this guy located. Then this guy, since he's a L3 who knows both of them, he will say that this guy is located at this interface. Now the packet will come directly to this once it gets the information. That is why you will see when you do the ping between one network to another network, always your first packet is dropped, then you get the exclamation mark stating that success ping. Why this dot? Because your packet didn't go directly to it. Your packet went to this, got the information. So that time the TTL got 0. Time to live got 0, which is where this is recorded as not reachable. Once it gets the information of which switch port this is connected, then it will directly be passing on to this, because now its R per table is been populating. It knows that where is the IP, or where is this being located. Okay, so that's a switch. This is also one of the switch model 3750. So you can see few labels here. These are the switch port. These are the uplinks. So you can see SFP module. So that means you can also have a optic fiber with the help of SFP injected to it. And if your uplinks are RJ45, then you can also connect them directly to this. This is the distribution switch. You will see all dual redundancy factors here. You will see 2 PSU and also hot swappable. So one get damaged, you can take it out RMA, and meanwhile this will be working and etc. So you can see the different line cards and the different soup engines. So you can have all this line cards to connect with the access layers. So this is used in the distribution layer, this kind of devices. Okay, when we proceed further in detail, we will be talking about some attacks, right? Like attacks seen on control plane, management plane, and data plane. Also, we sometimes later we will talk about SDN, like SD-WAN or ACI or DNAC. So why I'm talking this are, you should understand that your data, not data traffic, let's say your traffic over on the switch goes in a different planes. Okay, say for example, if this is a switch, a regular switch. So in a regular switch, what happens is there is only one common resource that is handling all the three planes. So if a network engineer is trying to do SSH is considered as a management traffic, right? Because he's just accessing it over on SSH or Telnet or SNMP protocol to see the whereabouts of the device, to see what is the counter, what is the status, what is the things here. Now, this is also increasing the CPU, RAM, or in short, the overhead of the device. Similar way, you get a traffic, let's say from a user who is meant to travel to some other PC. Now, let's say this is a data plane traffic. Let's say it's some sort of ping that he did. Now, it's the same CPU and RAM, which is again increasing. Right? Because this is having a single plane. This is having a single chassis for having all the three planes. Control plane is when it's the protocol that is talking. Say, for example, you had OSPF, traffic. So when the OSPF routing traffic comes to it, it will be sending its control plane, check where is this destination. It comes to know the destination is at this point and it will go out. So there are three planes that is basically managing. Control plane is all your protocol decisions, where to go, how to go. That all happens in the control plane. Data plane is your user plane. Sorry, management plane is your user plane, and data plane is when the packets are either originating from the same device, or it's just a a ping packet, or any CDP packet and all those things. Then it will pass it via the data plane itself. So in the device, in the traditional device, you will see them all within one device, and the resource utilization is more, which which is not good these days. Because if in case, let's say you get a severe management plane attack, then what happens is it can put that device down, and all your rest of the things might also get impacted. Or let's say someone does a control plane attack. Now, since a single device has all the three planes within it, like this kind of devices, the whole device is non-usable, or the quality starts. So this is why the SDN comes. In the case of SDN, what we do, we abstract the layers. So we keep the data with the actual physical units, which only does the work of forwarding the packet. And the control plane and the management plane, we abstract it, and we have this controllers these days. So you might have heard that in the case of SD-WAN, we have vManager. Similar way, you have Epic for ACI, and you have the DNAC for the SD access. So this is where the control and the management is nowadays being used. So if I want to access the inventory list, I'm not going directly to the device, right? I don't go to any device. I only go and take the graphical access via HTTP to these controller, and from there I generate the inventory list, right? If I want to have a forwarding packet, let's say this is a user, and he wants to communicate with this. So that is being handled with the data plane only. So the planes are abstracted these days to avoid any overutilization of one plane should not impact the rest of the thing. Nowadays, most of the time you see in the enterprise, the solution is SD access, where the DNAC is acting as your management and control plane. And in the data center scenario, you might be using ACI or any other ACI alternative solution. For WAN, you have these days SD-WAN, where you can pull all the inventories, you can push the certificate policies without going to any devices. In fact, everything has been abstracted. So these are those planes that we call control plane, management plane, and data plane. Yeah, these are the reading materials. So you can read what exactly the control plane is. So control plane all deals with your routing protocols. So any routing traffic comes, like we call it as special packet, which is nothing but routing packet. So if a routing packet comes, it goes to the control plane. It will check the database, like OSPF neighbor table, or the database table, and from there it will get to know where is the existing gateway to go outside. And if the traffic is just origin from the same device, or it's just a ping packet, it will directly go via the data plane. In our older devices, all the three kept it together. Nowadays, you will see they are being abstracted. So you will not be impacted with the other things. These are some of the type of switches. You have catalyst switch, you have nexus switch, data center. You have some modular switches which are used in the industries. Some fixed switch, stackable switches. So stackable is like let's say you have three switches. You can stack them up, You can you can come with the concept of like context ID or user ID. So you can decide one is master, second one is slave. Let's say this is third and this is fourth. So what happens is the downstream person or the upstream person, they see this 3 units as a single box. Okay, they will see this as a single box. So the HTTP blocking, the HTTP unwanted blocking of a port, that and all can be avoidable. And also, since it's a in the stack, uh, your throughputs can be increased. If let's say one goes down for some reason, one goes down, you still have the others working, right? So for a better benefit, these stackables are used. There is a stackable cables. So you can see the connection, how they are connected. So one from this to this, second to here, third over here, and the fourth one over here. So this is how the connectivity of stackable. And from the software, we have to specify which is master, which is second, for second, third, and so on. Okay, so next we are going to routers. Routers are from the look wise very similar to switch, but from the functionality they are totally different. So far we were discussing about the frames, we were talking about users, we were talking about end users, which are directly connected to the switches. But now we are talking about routers. So routers can be connected to ISP, it can be connected to a different router, it can be connected to the downstream switch where for the inter VLAN communication, could be any specific reason there. So how does routing or how does router works, or how does, say first let's see how this switch work. See in switch, okay, in switch, let's say you got the PC1 and you have PC2. Let us assume they are all in the same VLAN. Let's say they are all in the VLAN 100. That means this is configured on VLAN 100, VLAN 100, VLAN 100, and this is VLAN 100. Now, whenever you ping for the very first time, the MAC address table would not be formed, right, on a brand new switch. So it doesn't know how to reach this in simple words. So what the switch port will do, it will do the broadcast to all the other switch port which is belonging in the same VLAN. So it will broadcast to this and ask, do you know this guy? He will also broadcast here and he will also broadcast here. These people will decline. That means they will drop because they say, I don't know where is this connected. Whereas this switch port, since it's connected to this PC, he will record it over on the MAC address table and also inform the other person, yeah, this is located at this. And that is when the MAC address table will be formed. And then onwards, this will be kind of a unicast uh, based on when the MAC address is formed, when the packet is aware that BB is located at fast Ethernet 0/4 and MAC address AA is located behind fast Ethernet 0. So when these entries are formed in the MAC address, then they go unicast. Otherwise, when they are not, they do the broadcast work. So broadcast is like flooding to all the available switch port configured on, let's say, this VLAN. Now, when talking to routers, they are very different. Only the physical appearance looks that they would be they might look same, but not from the functionality. These are switch port. Let us assume you have one switch here connecting to this, and you have a user here. Similar way, you have a switch here, you have some users connecting to this. Let's say this is VLAN 10. Let me say this is also VLAN 10. VLAN 10, VLAN 10. When we are talking from the same VLAN, then the path will be this. They will not disturb the layer 3 device. The communication will be MAC based. The flooding will happen. They will make the MAC address table, and the communication will only be limited to this. But let's say if I would have another VLAN, let's say VLAN 30 and VLAN 10, which are in two different gateways. Now what happens is this will go to the switch. Switch will forward it, or switch will do the switching to the port. This will check the routing table. It will see where is this VLAN 10 IP connected, and then it will not do the broadcast. It always work on the unicast basis. It will forward to this, and it will see whether that's the IP, get the reply to this, and send it back and send it back. So that gets involved when you have two VLANs. Remember, you need to have a layer 3 gateway where it will check the routing table, and it will see if there's a known path to reach the destination. If it doesn't know, then it will drop the packet saying that destination is not reachable. Okay, and this is about the routing decision, because now you know that when a packet arrives to a router has to make the routing decision. Might be it is sending to control plane and then deciding whether to go out from here, or from here, or from here, any of the paths. So how is it making the decision? Okay, that is what this slides talked about. Let's say you have received here, and you have three different ports for your traffic to be sent out. So you received here, goes to control plane. Now, should it go via this and let's say connect to whatsoever this is, or it might to have to go via this, or via this to a different path. So you should know there are three thumb rules. The first one is called as the longest prefix match. Longest prefix match. So that means the router will check whether the query came for this, or this, or this, for the same, let's say, broader network, let's say 192.168.1.0. So is the packet coming for 30, 28, 20? That means, let's say this is 30, this is 28, this is 20. So the packet comes for which prefix? So let's say the packet came for 192.168 1 dot let's say 24. So this is the ping packet which is coming. Now the decision will go to this, considering that it's the longest prefixes. So you know the CIDR value, right? It starts with the 0 and goes till /32. So 30 means two free IPs here. So assuming that this is the longest prefix, the packet will be sent to this. Okay. But for some reason, let's say all of them are having the same prefixes. Same prefix in the sense all of them are at 30. Okay, all of these are 30. So in that case, this is not applicable. You have to check uh, longest prefix match and AD value. AD value in the sense administrative value or administrative distance. So what is AD value? AD value in the sense the trustworthy of the known path. So let's say you are learning this via static. Might be you're learning this via OSPF. Might be you're learning this via EIGRP. Okay, it's the same network now. All of three are same network, 192, 168, but learned via different protocol. Each protocol will have certain standard AD value. If you ever check for routing protocol AD values, you will get you will get a lot of recommended I mean a screenshot or details or document. So you can see here the AD value of OSPF is 110, and let's say the it's let's say for EIGRP it is 90, and let's say for static it is 1. So in the case of routing, we always give preference to lowest. It could be AD, the lowest is prefixed. It can be cost, lowest is prefixed. Lower is preferred. So for routers, always keep in mind lowest is preferred. Whereas in the switching, the higher value is always most of the time gets counted. Like you're counting the STP, whatever is the higher costing that is getting considered. Not always, but most of the time this is what it happens. So in the case of routing, we will check the AD values and the metric or the cost, and that is how we decide. So here in this case, as we know, static value is having a lower AD value, so high chances your routing will take the decision to go via static only, via this red path, because this is at the moment it is winning the election. But what if the scenario is still more time maker, something like all these things are being read by the same protocol. So let's say administrative distance. Administrative distance is tie right now. You have all of them OSPF. You have all of them of OSPF. Now let's say you receive a packet 192.168 1.1/30. All of them are OSPF, right? But there can be a different medium or technology used. Might be like, let's say this path is cat 6, or might be this is using a fast ethernet. Might be here you have two or more switches connected, so might be the path the cost has increased now. Might be here you will find one ethernet port. Might be this is a ethernet port which has a higher cost value. Now the cost will come into consideration, which is called as metric, and the lower will win the election. So whichever is the shortest path, that way the route will be set. So these are the three decision makers. One is the longest prefix match, administrative distance, and cost metric. Okay, so let me see how many slides we have. Okay, let me just go through quickly and we can wrap up for today. So this is a Cisco ASA firewalls. Firewalls are usually uh, layer 2 to layer 7. Layer 2 to layer 7 devices. The one which you have right now is a traditional Cisco ASA, which works on layer 2 to layer 4. Nowadays, Cisco has the next gen firewalls, which are Firepowers or Palo Alto from multi vendor or FortiGate. So those are all the the next gen firewalls. So the concept of firewalls are implicit deny. So let's say you have this firewall and you just inject it to your network. So any packet that you receive, by default, it will be implicit deny. What happens in the case of routers? In the routers, it's always allowed. You send any packet, they will forward. When will they not forward? When they don't know the destination. Might be you don't have the routing. Might be you don't know where the destination is. In that case, it will drop it. But it is not dropping because of any security concerns. It is just dropping because it don't know where to send it. So routers are always allow. They're always allow concept. You are sending something, routers will take the decision to forward. That is how router work. But at the in the case of firewalls, you send anything, they first have to suffer deny until you make the policy. So once you add the policy, then depending upon whether they are allow or they are deny, they do the needful thing. So if it is to allow the traffic, okay, then the traffic will be pushed. So that is Cisco ASA. They are not a major topic here in enterprise at least, so you don't have to worry. Neither you have much topic or configuration needed in the enterprise thing. In the enterprise, it's your router switches and the other aspect here. We will not have much ASA things here, but we will have one topic just to understand this from the topic point of view. This is the packet flow of a firewall. So you can see here when the connections are being entering, the interface counter increase. It will check if the connection is present. If the connections are present, then it will bypass. That's stateful connections or stateful engine that keeps the record, right? And then it will pass it on to the next module, and it will check the outgoing interface and outgoing the L2 header, and it will go out. If in the case the connection was new, then it will go via this three additional steps. So it will check the ACL permit, it will check the XLATE rules, and then it will make the record, and then it will get into the outgoing direction. So that is in the case of ASA. Okay, this is a wireless controller. Now, if in case you have not heard or not seen any access point, so the one which on the screen is access Air OS access point, manufactured by Cisco. So most of the enterprise nowadays have access point kept on the ceilings or on the roof, right? Let's say you have 500 cubicles, okay, within a office, within let's say 5 floors, you definitely would have cubicles and etc. So access point usually are deployed on the roof, so that it are not kept somewhere under the table, gets powered off, cables gets come out, or someone plugs it and take it home. So for any reason, they keep it at the top on the roof, so that it's not been disturbed or it's not been stolen from the office, because they are very small unit. You have to keep it in every corner, and at the center any housekeeping guy can take it and go home and might steal it, right? So they're somewhere kept at the top because of range also. If you keep it in the top, might be a lot of people can be covered in with one circle. Now, what happens is, let's say for 500 cubicle, you might have deployed, let's say 300 access point. Now, how do you manage this access point? Now, these are not your home access point. That once you plug it for next 10 years, you are not going to upgrade the firmware or any patches or any security things, right? These are the enterprise access point. These access points are much more configurable than our home routers. You have to manage them. You have to apply the patch. You have to apply the security rules. You might have to do the VLAN configuration. You might have to do any XY reason. So for that, we are using the wireless controller. In the short form, we write it as WLC. Now VLC is like the dashboard, which dashboard, or I can say, let's say this is a physical gear or physical devices, which is connected with several other access points kept in the different location. You don't have to go to each access point to upgrade them. You can directly log into wireless, and from the wireless, you can take the control of each access point. So let's say someone say the access point kept at rack 201, floor 10, cubicle 303 is not releasing the IP. So might be this access point is stuck. You might have to restart. You will go to WLC. You will check the label. You will go to that device and restart the services and see if that brings up its DHCP now. Or you come to know that one of your access point is running on some firmware 2.10.13, where there is a bug found, there is a security breach or security you know a security bundle has to be upgraded. So all the things you can do from the wireless controller. You don't have to go to each access point. You can take the control of WLC and push the needful function. Okay, these are some servers. Basically, these servers are also end point and also used for hosting the applications or web pages and your payroll database and all those purposes. Okay, so these are like UCS boxes. They can be a rack based servers which can be used as a server based. So most of the time, network engineers don't do the config of this. There would be a different team who does this for server or for the storage. Just for your understanding, what are the network components? I've kept this. So this is a Cisco server. This is the storage device. This is the data center look and feel. Okay, again, you would not be working from the data center, you would be working from remote. You should understand the concept of hot swappable or identifying the port number or identifying the cable, because if a field engineer walks in, you have to guide him which device, which rack, which location, so that he can go replace the cable, replace the SFP module, replace the PSU unit, right? So that for that information, you for that purpose, you should need to know the concept of CDP, because these protocol will help you to actually find the needful information. CDP, or with the help of show SNMP, you can find more information about the location about that particular device. The switch port can be found with show IP int brief command. The versions you can find, because sometimes what happen, you might give some detail, but the field engineer wants to double check by the help of serial number. So all the device at the back, they also put the serial number and the model number. So to just to verify that you both are talking on from the same device, might be there's a mismatch. So these are some data centers which are located for a different MNCs. Okay. So this ends our first PDF. So I think for today we are good. So next I will take in the next class because that would be another few number of topic which I think we can't complete today. So let better we can have it in the next class. So you guys have any doubt from today's session?
Yes, I have some questions.
Yeah, go ahead.
So when you mentioned about the architecture and the especially the three-tier architecture, I'm seeing like a lot of stuff that going to data centers, especially in like having a spoke architecture.
Mhm.
So and sometimes I get confused with this. So the distribution layer, it will be hosted in a data center or it just be hosted internally. It will depends on on how large is the network.
See, the things will be kept. 1 second. So the things will be kept in the same rack also. If you see this diagram, so here only we can have a different. Say for example, this is now let's say distribution. Okay, and let's say they would have a core connected to this.
Okay.
And later this would go via the jack panels to the floor where you might have the access switches which are connecting to the systems or the servers. Okay, so they would be cable. The core and the distribution would be very close enough, whereas the access layer switches would be kept somewhere closer to the users because that is somewhere connecting with the users. That's it.
Okay. So all right. So in the case of like uh because what we have is just we have a connection. Most of the controllers are in the data centers. So the connection go all to the data centers to the controllers, and the controllers kind of redirect the traffic to the destination, I guess.
Yeah, exactly. Yeah.
Okay. And another thing is I always get confused with the terms in I hear like a lot of times they say this is a border switch, this is a H switch, or is that comes the same as a core or distribution switch?
Yes, you can think your core act called as a border or edge as well.
Okay.
Yeah. So that's also canonical names used edge routers, which means connecting to ISP, or border router that means it's connecting to an ISP.
Okay. Thank you.
Okay, so any other question? I think Sid joined recently. Rest I see all, and also Herald had joined recently, I think. So we had some interaction to understand the participant background. So if you want, you can also let me know your technical background. Are you from CCNA level, or have you done CCNA, and what number of experience you have it here in enterprise?
Hi, Sagar. I'm Harold.
Yeah, yeah.
Uh,
Yes.
I have 5 years of experience in networking only,
Mm,
almost 6 years now.
mm.
And when comes to networking, I'm good with CCNA level topics like what all we discuss now on some other topics, but not in a packet level, like Wireshark, everything I did, but in a very basic things, theory part, you can say. And when comes to my work experience in work, we will definitely do things, but they are limited. So I just want to expand my knowledge. Currently, I'm with Aruba things. So and everything, Cisco and Aruba are almost the same. So I just want to expand my boundaries and know networking in packet level.
Mhm.
That's how.